topic for it. All right, so can you guys see my screen now?
Yes, sir.
Yes, sir.
Okay. So before we proceed to the last module, which is the software quality and then testing, let me ask you guys first. Is anyone who has a question or clarification until week 7 to week 10 with the, I don't know, maybe with the activity or with the module itself or with the case studies? Anything regarding with week 7 to 10? Anyone? If none, can you guys give me a quick thumbs up to let me know that you don't have a question? Okay, great. So like 12 out of 14 responded. I don't know what happened to the other two. Anyway, so let us start now with our last module, which is the software quality and testing. Okay, well, supposedly this is the two separate module, but it can be combined as one already, as you guys can see right here. Software quality and testing, since they are connected with each other anyway. So let's proceed, or with let's start with the module overview first. So as usual, you will see here the topic learning outcomes. So in here, of course, you'll know the definition of quality, cause of quality, and then quality model. Apply testing and inspection techniques. Know how test tools can be used in the testing life cycle, and then use testing metrics for product and process, and then understand how to do performance testing and usability testing. And then here are the list of topics that will be discussed under the module. So software quality management system. So what is that? And then what is the evolution of quality management system? And then the concepts or its principles of software testing, and then types of software testing. So we only have one module, and then can guys check this two external links that came from YouTube and explaining what is this quality assurance versus quality control, and then what is this software testing tutorials for beginners. This is an hour of video, so this will teach you the fundamentals on what is software testing really is. Okay, so please check them out later on. Okay, and then we have one PDF which is quite long, which talks about software testing and then quality assurance theory and practices by these two authors. I don't know how to pronounce their name, but yeah, these are their names. Okay, so just check this PDF later on if you need more information regarding software quality and then testing. Okay, so it's loading. So yeah, and then here's the reference, which is see in the tutorials point. So this is a 600 pages, which talks about how the testing started, and then what are the methods that they're using before. So before it's like a pseudocoding and a flow algorithm. So yeah, and then most likely those are like formulas or algorithms that you have to use. Okay. So most likely uh, flow charts, and how to explain things under this PDF. Okay. Anyway, so yeah, that's it for the module overview. So are we clear so far regarding with this one? Hello, are
Yes,
you
sir.
guys able to follow?
Yes, sir.
Yes, sir.
Yes, sir.
Makain nga. Or baka natutulog yata ulit kayo ah. Anyway, so I guess we can proceed now to the module itself. So well, nothing new in Underwatch videos. There is no pre-made video. Okay, just the external links came from YouTube. And we have the one activity, okay, which we'll discuss later on, and then of course one case study. Okay, So without further ado, let's start now with software quality and testing. So let's start by defining what is software quality. I guess, uh, even though without reading definition and description, you guys already know what the software quality means. But yeah, this one is actually subjective. That is the one thing that you guys need to know when it comes to the word software quality. Software quality product is defined in terms of its fitness of purpose. Okay, that is a quality product that's precisely what the users want it to do. Okay, so we could say that the quality is already good once the user or one who's going to buy your product already approves, everything. Okay, so for example, the one who's going to buy it says, okay, it's very good, 90% of it or 95% of it are already perfect, working fine. But let's say you applied for a certification wherein it's a big company wherein you're going to check your product, uh, actually has a lot of failures. Like it only passed 50%, so it's barely passing only. So we could say that it's subjective to the person or to the company who's going to test your product. But of course, we have these standards already. Like for example, we have this so-called portability, usability, the usability, correctness, and then maintainability. So if you were able to, suffice those, let's say, call this one quality, okay, product quality or quality or for whatever quality check, like portability checking, usability checking. So if those are already enough, then let's say 80% we're able to pass the portability of that software. Usability is at least 80 to 85%. Then we could say that the quality of the product is already good. Okay, but then again, that still depends to the user, most likely the one who's going to buy your product. Okay. Anyway, so what are these standards that we have to take notes? Number one is portability, or should I say compatibility instead of portability? Okay, so a software device is said to be portable or compatible if it can be freely made to work in various operating system environments, in multiple machines, with other software products or etc. Okay, so in other words, it should be compatible with a lot of with various operating systems, with multiple machines, etc., etc. Okay, so I don't know why they call this one portability, because when we see portability, it's like more on physical thing, like the PSP. It's called PSP because it's portable PlayStation. Okay, so you can or I don't know what you call the one, PS Vita, the new one, or yung the Nintendo Switch or whatever, handheld games that you can play using your hand only, and then you can carry it anywhere you want. So that's why it's called portable. But in here, it's like more on compatibility, because it's I don't carry that physically. It's like more on the compatibility to that software or to that operating system. So yeah, that's why I mentioned, or I did say compatibility instead of portability. Anyway, next one is usability. I guess this one is very obvious. So a software product has better usability if various categories of users can easily invoke the functions of the product. In other words, it should be user friendly as much as possible. Without reading the manual, without reading the uh, let's say configurations, you already know what does this button or what does this function do. Okay, so it can easily follow. Okay, so usability. Next one is reusability. Of course, software product has excellent reusability in different modules of the product, can quickly be reused to develop new products. So like for example, they can recycle your project or program to create another product. Okay, reusability. And then second to last is correctness. Of course, a software product is correct if various requirements as specified in the SRS document have been correctly implemented. Of course, everything that we have mentioned on your document should be, matching with the actual product. So if you've mentioned in your document that it can perform 90% stable, then it should perform 90% stable on the actual test. Okay, and then last one is maintainability. Of course, software product is maintainable if bugs can be easily corrected as and when they show up. So new tasks can be easily added to the product, and the functionalities of the product can be easily modified. So I guess they are quite straightforward. Okay, just, without reading description, you already know what usability, portability, and so on and so forth means. Okay, so are we clear so far up to this point? Were you guys
Yes, sir.
well,
Yes,
so
sir.
Yes, sir.
Yes, sir.
Okay, good. So next one is software quality management system. Now, this management system is like, one faction, or let's say, sometimes it's not just a faction of a company. Sometimes it's another company. Okay, so they hire another company to test your system. Okay, so it is a quality management system is the principal methods used by organizations to provide that the products they develop have the desired quality. So it could be say 3 people, sometimes 10 people, or sometimes composed of 30 to 50 people. Say another company just tests your product. Okay, and then here's a quality system subsys, or composed of subsystems under this management system. So number one is the managerial structure and individual responsibilities. Okay, so under this, a quality system is the responsibility of the organization as a whole, of course. Okay, however, every organization has a severe quality department to perform various quality system activities. So in other words, yeah, that is one function, but it has to be separated into severe quality function testing. So this one needs to test the, let's say, first and second phase of the product. So what is the mid, say mid process, and then the last one is the, let's see, the post process or the end process. Okay, so we can say something like that. So it's divided into three, three parts, okay, of that subsystem. Okay, so in here it's just being divided into from, say, from start up to the end process of the product. Okay, and then the next one is quality system activities. So of course, I think this one happens all throughout the processing from the very start up to the end of testing process. So of course, auditing of projects, review of the quality system, and then development of standards, methods, and guidelines, etc. Production of documents for the top management summarizing the effectiveness of the quality system in the organization. So this one is more likely checking the documents, checking the process from time to time, and then reviewing the process or the quality of the system from time to time. Okay. And then the next one is evolution of quality management system. So when we say software quality management system, I would say this is the biggest faction, okay, of that, let's say, company or group. Okay, so of course we have this so-called quality control. So I'm pretty sure that you guys always hearing this one in in every company. They have this quality control, quality assurance, QA, QC. Okay, but in here, let's start with what is this quality system first. So quality systems have increasingly evolved over the last 5 decades. So before World War II, the usual function to produce quality products was to inspect the finished products to remove defective devices. So that is their only goals, just to check, when, let's say, once the product was made, they're just going to check if it's working properly or not. If it's not working properly, then they have to remove it. As simple as that. Okay. And then since the time, quality systems of organizations have undergone through 4 steps of evolution. So before, it's just like one step. You just have to check, the final product. But in here, it evolves now. It's now a more improved ways of checking things. Okay, so that's why this QC comes up. Okay, or this quality control comes up under this quality system. So quality control target not only on detecting the defective devices and removes them, but also on determining the causes behind the defects. So before, you just have to check, if it's working or not. But right now, we have to know why is it not working. Okay, So that is why we have these 4 steps. Where are those? Okay. So we have this recognizing, defining, analyzing, and then improving the production process. So before we only have this quality system and then quality control, but there is this another quality check which is called quality assurance. So it evolves from quality system to quality control and then into quality assurance. Or let's just say we now have 2 standards. Okay, the quality control and then the quality assurance. So when we see quality control, it's just to check if it's working or not, and then to detect why is it not working. And then here comes the quality assurance wherein we have to detect the process, okay, along the way. And then let's say checking everything from step by step if it's good or no, okay, to avoid having quality let's say failed or call this one, what is the most proper term, defective, or it's not, there is a more proper term, so to avoid that defective output or defective product. Okay, so yeah, this is the evolution. So we only have this quality check before, let's say from product assurance up to the process assurance. And then we now have this quality assurance or the product assurance itself, okay, wherein we have to inspect, we have the quality control along the way, and then quality assurance, and then the total quality management or the TQM. Okay. Well, anyway, so this one is actually quite confusing. So let me give you guys another diagram which is similar with this one. Quality assurance versus quality control. I think this one is very good. Okay, so we have this now QA, so, and then a QC. So QA stands for quality assurance, and then QC stands for quality control. So QA again is a managing tool, process-oriented, proactive strategy, prevention of defects, everyone's responsibility, and then perform in parallel with a project. While in quality control, it is a corrective tool, product-oriented, reactive strategy, detection of defects, testing team's responsibility, and then perform after the final product is ready. So you could easily tell that this one is that is happening from start up to the end, while the quality control only performs after the final product is ready. Okay, so yeah, that is the difference between QA and QC. Well, I think this one is just inside of this quality control and then quality assurance. So you can see that product assurance up to the process assurance right here. Okay, so anyway, this is like their evolution. Okay, from quality system up to the quality control, and then the last one is the additional one is the quality assurance. So all in all, we are now using only 2, which is the quality control and then the quality assurance. Okay, so are you guys able to follow so far on how does our evolution of quality management system from the start up to the end?
Yes, sir.
Okay, so
Yes, sir.
let's move on now to the second phase, which is the software testing. I guess this one is very straightforward. So software testing is of course to detect the bugs or errors of that system, or in other words, it's just evaluating if it's usable or not. Okay, so under this we have this reliability, scalability, portability, reusability, and usability, which was already mentioned right here. So I guess I don't need to discuss these attributes of software, this reliability, scalability, and so on and so forth. So I'll just skip that one. But software testing is to test whether it's working or not, or identifying the correctness software by considering it all the attributes. Okay. So again, what is testing? Which is again to test again if there is a bug, if there is an error, if there is a failure, and so on and so forth. So I guess there is no need to explain this paragraphs anymore. But yeah, of course, I'm gonna say testing in software, of course, talks about codes, talks about the maybe I don't know, the internals or what is happening inside of that system. And then of course, we also have this hardware part, of course. That's another kind of testing when it comes to physical or say the hardware of part of the system. Okay. But since our focus is only about software testing, so we will only focus about software testing, of course. We're not going to talk about hardware testing, okay, because that's another, different broad topic. So we have this various types of testing available in the market, which are used to test the application of application or the software. So with the help of the low image, we can easily understand the types of software testing. So it's divided into two. We have the manual and automation. So mostly in most say platforms or coding platforms can detect, let's say, 10% or 10 to 15% of the errors or bugs that is happening on your system. So that is under automation, or you can use another complete software or another application just to test or just to run everything on your system. So that's still under automation. But mostly, we do manual when it comes to software testing. Okay, so it is divided into three parts, which is the white box testing, black box testing, and then gray box testing. So I guess it's easier to white box testing versus black box and then gray box. Okay. So when we see black box testing, we don't okay, just wait a second. I guess you guys cannot see this one, right? This one is quite pixelated. Okay, I guess this one is better. So black box testing, you don't know anything. So let's say your company uses another function of that company wherein I know nothing about the system. So with this one, you're going to check everything from zero up to the end. Okay. So it's like you're checking the system or you're testing the system as an attacker. Okay, that's how you approach this black box testing. But let's say white box testing, it's like you're the developer. You're the one who develops systems. You're the one who knows which part of your system like most likely to have an error, like most likely to have a bug, like most likely it's not stable, and so on and so forth. Okay, so you have the full knowledge. Okay, so most likely we don't do this one because you're going to be biased. Of course, let's say you're the developer. Of course, you will see that this one doesn't have an error anymore. Of course, okay. So why would you want to suffer? Why would you want to check your system if you can just uh let the other faction of the company or other team to check your system, because that's the job. Your only job is to check your only job is to create the software. So of course, you will say that everything is working. You will see that everything is already perfect. But when it comes to, let's say, this another team, which is to check your system, of course, they will do everything just to find an error or a bug or whatsoever that is incorrect that is happening on your system. Okay, and then we also have this gray, which is not that let's just say that this is another company who doesn't care if there is an error or if it doesn't have an error. Okay, so it has some knowledge on what is happening on the system. Okay, but it doesn't know everything. Okay, so testing as user with access to some data. So you can say that this is a beta test that you want them to test your system. Of course, they're not going to go through with everything. They're just going to test maybe the basics from the login, registration to login, the navigating things on the dashboard, navigating things on the functionalities, going to the settings, and then what they can see. where they can, just click anything, and then if they found out something, then we will just report it. Okay, so a company, I mean a team that will really test your system, okay, from start to the end, and then someone who just created the system, of course, will say that everything is good. And then this is just a random person who's going to, let's say, test your system. Okay, so those are the differences between white box testing, black box testing, and gray box testing. Okay, so yeah, so black box testing is the one that we most likely would like to go when it comes to manual. Okay, that is why white box testing and gray box testing is not further defined under this diagram, or say flow chart. So of course, black box testing will test this functional and then non-functional. We have this unit testing, integration, system testing, or this is say everything. It will check everything under this black box testing. Okay, so were you guys able to follow what is this black box, gray box, and then white box? Hello, hello. Are you guys still around?
Yes, sir.
Yes, sir.
Okay. Anyway, so last topic will be the software testing principles. So these are the things that might happen, upon testing a certain system. So the first one is testing shows the presence of defects. Of course, we do testing to see if there is a bug or if there is an error. Okay, that's all about what this testing shows, the presence of defects. I guess from the title itself, it's very straightforward. You don't really need to, read the definition, but just more information, just learn more about what is this testing shows the presence of defects. And I mean, that's already all about what it's trying to say. And the next one is exhaustive testing is not possible. So from the word exhaustive testing, like you're going to check everything. So that actually is not possible. Okay, so if it's a small project, I guess it's possible, though it's still not foolproof. I mean, it still won't be able to check the 100% potential if there is really no error or no see a bug of that system anymore. You cannot say 100% this one is perfect. Okay? There is no such software or system. There is always a 1% error, even though you have checked. You have, let's say, all the certifications. You have all the let's say big companies tested your system. There is always a room for errors. Okay? There is no such thing as perfect system. Okay, and then early testing, I guess this one is the common sense already for, especially for the white box testing or the developers itself. So of course, he's going to check if everything is working as it should be. Okay, and then we have defect clustering. Well, this one is very effective if, let's see, you're having a hard time figuring out, which of your modules or which of your codes is having or causing that an error. So in here, we can detect the numbers of bugs which are correlated to a small number of modules. So for example, you have, let's say, 100 modules, and then there is this one module which is, having an error. And then most likely, of course, it's correlated to the other modules, let's say 10 or 20 modules. So all you have to do is check that 20 modules instead of checking everything. Okay, so we call it one defect clustering. Okay, which is again another common sense if you are testing something. So you have to pinpoint which of your module causing that error for you to be able to narrow down, what the modules that you're going to test. And then we have this pesticide paradox wherein when we say pesticide, so it's kind of similar actually with the later pesticide to kill pests in our plants. But of course, we have different types of pesticides, right? So this pesticide is just to kill this, let's say, 5 kinds of pesticides, and then there is this new pesticide that cannot be killed by this pesticide that you're using right now. So of course, you have to buy another pesticide just to kill that pest on your plant. So this is similar with your system. So if you keep on using the same testing process, you're not improving the testing process, then of course you won't be able to detect new and different let's see, errors or bugs on your system. So of course, new and different tests are necessary to be written for the implementation of multiple parts of the application or the software, which helps us to find more bugs. So in other words, you just have to improve your testing process. Do not just stick with with your old and same process. And then testing is context dependent. So in other words, we have different ways of testing different platforms. So if it's Android application, you have this types of testing only. If this is, let's say, uh, a website, then we have this different ways of testing these websites. This is, let's see, a standalone application. So we have another test or different tests that you have to do under this standalone application. So in other words, it is a context-dependent principle, okay, or it has multiple fields such as e-commerce, commercial websites, and so on available on the market. So I just mentioned a broader topic. So in here, it just talks about a website. So we have commerce website, commercial website, okay, and so on and so forth. And then last one is absence of errors fallacy. So it's just saying here that, again, there is no perfect application. So once the application is completely tested and there are no bugs identified before the release, so we can see that the application is 99% bug free, but there is the chance when the application is tested beside the incorrect performance, identify the flaws and fix them on a given period would not help as testing is done on the wrong specification, which does not apply to the client's requirements. So the absence of error fallacy means identifying and fixing the bugs would help if the application is impractical and not be able to accomplish the client's requirements and needs. So in other words, you just have to check, or this is you just have to fix what is your user, let's say, having a hard time to use with. Okay, so some part of your system or some part of that system has an error, but doesn't need to be used by the user. So I guess you could say that it's already 99% bug free. Okay. Well, if there is this another user which is using that function, and then of course that is not 99% anymore, then you have to fix it one, and then just satisfy your user, then it's another 99% bug free. Then if they found another one, then you have to fix it one again. So in other words, just have to satisfy your user. Okay, so there is always an error to a certain software or a system. Okay, so yeah, that's it for the concepts and what is this software quality and testing. So were you guys able to follow everything?
Yes, sir.
Does anyone has a question?
Wala naman po, sir.
Okay, so let's proceed now with your last activity. So this is already the last one. So in here, you're just going to identify the methods, steps, or tools, if there is, that you have used, okay, to test your software or system project and its quality. Okay, so this one can be done on your software design laboratory. So of course, that is where you are creating the project. Okay, so of course, I would like you guys to, to test, to check your system if it's already bug free. Okay, and then the last one, which is case study number 6. So software testing is a process, blah, blah, blah. And then here's the question. Just share your experience while you're testing your proposed project. So did you discover a lot of bugs or errors in your system? If yes, just share at least 2 bugs or errors you have found on your system, and what do you think? So I have to add this one later on. What do you think is causing it to happen? Okay. So yeah, just answer this one. So yeah, I guess that's it. So any questions so far before we end our meeting?